let's have a look at the source fuel. I've just cashed out this just to sort of show. Let's have a look where I've got one that plays. I think it's that one. So this is where we are at the moment. All I've really done is just vary these source properties. Oops, where's he gone? There he is. And we're getting something quite good already, and some nice smoke and sort of explosiveness. And obviously it is quite explosive because we are adding quite a lot of speed and moving it out and adding that sort of turbulence to the sort of beginning of it. But there's also a level of what goes on here will also add to the sort of explosive nature of the combustion. So let me just click that back and stop it so it's not sitting in the background. Right, so we've got some basic parameters, the general ones, whether it's working or not, what frame it starts at. So basically this is going to sort of add fuel to this source air. So it's either adding it from the beginning forever, or you can define when it starts getting added. Then we've got the fuel properties, and you can see there's not many settings. First of all, we have this thing called fuel type, and we've got a drop down here of all these different ones. So one of the sort of aspects of this new combustion system, which I sort of mentioned last week, is how physically accurate it is to real world situations. They've sort of tested it with sort of in the laboratory with, sorry, I'm clicking that, with in the lab with actual explosions, and the things that are going on inside the simulation match those real world data recording they've got from these sort of analysis. And one of the things they've added to it is there's different types of fuel types which match real world different types of fuel. Default is methane. I've got here this one. No, hang on. This one we were looking at. So this is methane. And this one is butane. No, don't do that. No, that's all right. So play that. And as you can see, there's not much difference. If I go to, say, the last frame, which is frame 50, stop that, go to frame 50, say this one to frame 50, differences in the shape, there seems to be slightly different smoke production, there's a bit more smoke going on in here earlier on, maybe, but not massively different, but there is differences to it. So, the reason for all these is apparently if you are working on a production, you've been on a shoot, they've done some real world SFX, i.e. actual physical explosions on set, and you know exactly what fuels they've used, whether they've used a mix of methane and butane and blah 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 and all this. You can bring all this information and you can daisy chain these fuels so you can add more into there and give the different fuel types and sort of as a percentage and whatnot, and sort of the amount that's going in and all this sort of stuff, and match those real world scenarios. So unless you're in that sort of situation, you may as well just leave these as the defaults for methane. I mean, you can play around with them, but as you can see, it's not. Oops, there's a render. There's not a massive amount of difference between the two. So. But feel free to play around with them. But I'm not sure. I haven't gone through and tested them all myself. But you never know. They might have completely different results, the other ones. But it seems to be quite subtle. So next one is the ignition temperature, which we've talked about briefly before. And this is at what point will the fuel combust, and what temperature. And the sort of temperature is dictated here. But now we're actually dictating it here with our very source property. So anything under 580 temperature wise will not combust. So I don't have to show it, but it's pretty obvious, it won't do it basically. So, but you can lower this to lower temperatures if you want. You don't have to have them quite high. That can have good effects on your simulation. But that's a sort of key point to sort of remember when you're playing around here. If it drops below this, or if I'd set my temp here to be this one below, you won't get any combustion. Right. So the next two are fairly sophisticated in their maths. I don't massively. This isn't an intuitive like slider. The more you crank it up, the more it's going to burn, the less percentage of oxygen. It is, but it's quite subtle, and it's quite. If you change this to a big number, it can completely change the whole thing very quickly. So what these are is the percentage of oxygen in they call it in the oxidizer. So this is all proper physics going on here. So if you put the percentage to 0.4, the oxidizer will consist of 4% oxygen and 60% nitrogen. So, and typically it says here, increasing the oxygen percentage will lead to a more violent explosion, increasing frame propagation speeds and higher temperatures. So between 0 and 1, 0, no oxygen in the combustion oxidizer. You won't get you will get, it won't be 0, like you won't get no, because obviously you need oxygen to burn, but if you put this at 0, you will still get an explosion because there is ambient air in this whole thing going on, I think. So let's just try that. I'll put that down to point. So we're on methane. This was my methane one. That might be my butane one. Let me just close. Which one's that one? Yeah, that is methane. So that's my methane one. Let's close the other one. That one. I'm going to close that. So I'm just going to change the thing to say 0.2. I'm going to pause and read. So this simmed out 25 frames of that, and this is obviously with the oxygen level at 0.2. Is it 0.2? And you can see there's not much difference really. There's a slightly, this perhaps when it was at 1, a little bit bigger, but not much. I don't think I moved the camera. It looks pretty much the same. I may have slightly moved the camera. So you can see it's not having that much an effect. Let's try it again at like a really low number. Minimize that. We'll try this at 0.01. And I'll pause that. Just make sure I am on right mode. Rewind. Hit play. Then I'll pause. So I've simmed out the combustion with a percentage of 0.01, and as you can see, I've done a little play blast of that. Yeah, you do now get completely different results. You can see there's not much oxygen, so it's sort of burning out really quickly. You're getting more of a sort of flame that's sort of hanging on to life sort of thing. If you compare it to the other one, where are you gone? There we go. So that's with oxygen at 1, and that's the only thing I've changed. So you're getting that, and then at 0.1 you're getting that. Yeah, so you do, but as again, it's sort of showing that these sort of numbers, they can get quite small, or you see the burn rate here is only at 0.05. So making sort of large changes can make quite a big difference. Put that back to 1 just so we get where we were before, and we'll have a look at the burn rate. So I don't 100% understand what's visually going on when you change this, because it's quite a complicated physics thing. So it's a value between 0 and 2. So between 0 and 1, when after the sort of combustion happens, so this is probably sort of like almost like a per, you know, molecular level almost, I don't know, but sort of when that combustion happens, between 0 and 1, you are going to be left with an excess of fuel. So you're not going to use up all the fuel in the combustion oxidizer, as it were. So at the moment, we're hardly using up any of the fuel when we burn, so we're getting quite a lot of burn going on, I suppose. And this is how, you know, visually I can't quite work it out in my mind what's going on. So at 1, you are getting all the fuel and all the oxygen burnt up. At 0, you are getting none of the fuel burnt, I would have thought. Hang on. So let's do that at 0. Let's see what happens very quickly. I have to put this back to right. And then hit rewind. So we are still getting something. It's a lot smaller than it was. But there is obviously some combustion going on. Anyway, so stop that. Let's go back to our fuel. So 0.05 is the default. So if I go to, say, 1, and I now hit play, you can already see that's quite a lot brighter. I know it's quite far away, but let's just click that and see what happens. And you can see this is full of heat and temperature. It's all the oxygen's being used up, all the fuel's being used up, and it's just a big, massive boom of explosion. And there's not much info in it. It's just a big white flash of explosive material. So the more you go towards 1, the more it's going to use up the fuel. It's going to increase the explosiveness of it. It's going to increase the temperature of it, because obviously more stuff's being burnt, and you're going to get these sort of white out explosions, which ultimately will you know, as it travels through, it will start getting cooling down a bit. But you can see at the moment it's just full on white, intense super white heat. So let's stop that. And then from 1 to 2, you're going to get a situation where all of the fuel will be used, but not all the oxygen will. So 2 is basically not much of the oxygen is going to get, almost 0, and all the fuel is going to get. So it's a sort of, let me get my, let me just pause this. I'll let that preview out, see if anything happens, but I'm just going to pause. So I've just cashed that out at 2, and you can see nothing's happened. So basically, none of the oxygen is being used up. It says here, I'm just going to stop that. Let's go to here. Sorry, info on fuel. So burn rate is values of 1 indicate perfect stoichiometric metric conditions. That is, all available oxygen and fuel will react to form byproducts with no excess oxygen or fuel. Above 1 corresponds to a fueling conditions where there will be excess oxygen after the combustion. So at 2, which is what we've got at the moment, none of the oxygen is going to be used up. So that's why you're not really getting any explosion. So from a point of view of how I try to visualize it in my head, let me just go with a pen. So, is that going to work? What's going on? It's not working. I've got the pen, here we go. Sorry, it's playing up a bit. Come on. Maybe I'm doing something weird. Seems to be working. I've got some issues. There we go. Let's try that. So, is that going to work? It's really lagging. No, it's not. Oh, yeah, it's working, but slowly for some reason. Hang on, let me just pause. I'm going to pause and I'm going to draw it and come back. Right, so I couldn't get my thingy to work. A very frustrating couple of minutes. So this is what I think it's what's going on with those numbers is that at 0, no fuel is being used up, and then as you go up, and there they meet in the middle. So this is at 1 at this side of it, and they meet in the middle. They're both being used up 100% at this point. Let's do another. So that's all you do. And then as you go up to 2, the oxygen falls off. This stays as it is. That's how I visualise it. Whether that's actually what's happening, I'm not 100% sure. But that would seem to be like a very long bit of effort for that anyway, but we did it. So that's what I think what's happening. You're sort of getting this sort of build up. So, well, 1, they're going to have a perfect, everything's going to burn up. So really, I suppose the thing to take away from that is it's sort of, at this point here, everything's being used up. It's going to be the most combustible it can be, and then you're going to get this fall off, either one way to the fuel or one way to the oxygen, and that will have an effect on the look of it. But I think you've got to be quite subtle in your changes. Just be careful when you're sort of cranking these up to big numbers. You'll get or not big numbers, but going from like 0.001 to 1.8 might make everything go completely different. So just be wary of that. Right, so let's go back. So we've had a look at fuel. I'm just going to put that back to something. Well, let's put it to 0.2. Just see what we get. Right, we're going to hit. Make sure I'm caching. I am. Let's see what we get at 0.2, and then we'll move on to the combustion settings next. So you can see it's already quite hotter, more explosive, very white heat, but it should start to cool down a bit, and you can see it is already cooling down because you're getting, not just white anymore, but it started off very hot, so the temperatures aren't as high, but we're getting quite a volatile sort of explosion. Right, so the next video, that was a very long one, sorry about that, we'll go and look at the combustion settings.